Hello everyone, I am Bradley Sward, Associate Professor of Computer Information Science at the College of DuPage, Glen Ellen, Illinois. And this video today is going to look at Advent of Code 2020, Day 15 activities and festivities in my new favorite programming language in the entire world, Python. It's fun. I'm having fun doing these problems. And so here is my code, and Day 15, Rambunctious Recitation. And so you look at this and you go, oh my goodness, it's a number sequence. And for whatever reason, way back in the day, not way back, but way back enough, YouTube suggested one day that I should watch a video from Numberphile called Don't Know the Van X Sequence. And you can go through this, and if you want to, this problem today is derived smartly from this number sequence. And so it's very similar. It's a little different. The rules are slightly different, so you just can't go find the Van X sequence and just go crazy on it. And so what are we doing? It's the same kind of thing. The big difference between this problem and this problem is that you're starting out with a larger set of numbers than just an original number, just one number, and you're going from there. That little bit kind of makes things slightly more confusing, and depending on how robust you want to make your solution. I don't know. Again, I don't know how many of you at home and in your data set have a different value set than I do, and if you have duplicates and whatnot. But this works if the numbers in here are not duplicates. At least the last number is not a duplicate of something else. So this is the first time I think we had a data set that does not require a file, so I just jammed it in there and I just set it up as a list, like I've pretty much done for most of everything. But this time around we have to go ahead and turn that data into a dictionary, and you don't have to do this for part one, but I'm showing this for basically the entire solution, because if you want to be able to solve this in a reasonable amount of time for larger and larger numbers, you have to get away from going at big O of n, and you have to reduce it basically down to big O of 1, if you want to think of it that way. It only takes a moment to find out where the number has been in the sequence previously, or if it isn't in there at all. Well, maybe log n. We'll say log n because I'm using a dictionary structure. Yeah, definitely log n. Sorry, it's late. I have a giant monster headache, and it's time for bed. Okay, so this just converts. I don't know a better way to convert this into from a list into a dictionary that maintains both, like, I guess the key value pair of the key is the number of the the value, and then the value from that, the key value pair, the value is the index. This is at index 1, 2, 3, 4, 5, and 6. And so from here I have the dictionary. And without giving away the answer too quickly, for my data set anyway, I can just show you here if I print data. And you go, okay, there I go. So 2 gets the 1 location, 0 gets the 2, 1 gets the 3. I always thought this thing was organized. Well, maybe dictionaries are slightly different than sets. Or maybe that's organized. I don't know. It's been a while. My Python, again, is my newest language. I don't know the differences between a dictionary and a map per se in C++. But you get the point. Everything comes out just fine. And so we're good to go there. I have the data set up. And now I have to say here that my next value is 0. And I'm hard coding this because the 19 is the number that was the last number put in. But I know that 19 wasn't previously in here. So I'm gonna be putting a 0 in next to start this thing off. And if I knew that whatever number, say the last number here was a 5, I would have to put in a different next value, because if it was in there twice, I'd have to put it in a 1. Or if I'm looking for a 2, I'd have to put in a 1, 2, 3. I'd have to put in a 5. So I'd have to rewrite this code, and I don't want to do that because I have my solution and everything is good. And so this code will work for any endpoint. For part one asks you to do this all the way up to 2020. And so all you're doing is basically these 2 rules and just using a dictionary instead of a list to compute the next value. So if, and this starts off for like in this length plus 1, so the 7th number on all the way up to the endpointeth number is going to say if that next value, the 0, if it's already in the keys, If it's in here, in my dictionary, yep, it's there, it's a 0. Well, then we need to figure out how far away we are. And you say, in this case, 7 minus 5 gets me, or 7 minus 2 gets me 5. And so, so that's how, I think that's how far. I haven't run through and looked at my data. I remember all the data for the sample set. But anyway, so we say, okay, there's 5. Oh yeah, 0, duh. 1, 2, 3, 4, 5. Yeah, there's 5 elements between that. So I'm gonna say, yep, I'm gonna put that in there. That's already in there. The data at the 0 location gets the new location, and my next value is gonna be this value. And say otherwise, so I mean that's what happens if the value is already in there. You're just trying to figure out how many turns apart it is, set that to your new value, and then go ahead and make sure that you say that, okay, that number that you were looking for, it's updated, so now it's in the ith location. But if it's not in there, this is the first time you've seen it. So the next number around is going to be a 0, and then I'm just setting up, this is the same in both places. The data of whatever my value is, it's going to be reset every time. It's just a matter of, do I need to set up a new value or not? And this automatically sets up a new value, and this uses what was previously in there. And so like any number sequence, it's only 2 rules, if, else, and I've handled all the cases for how to handle each individual addition to this thing. Once you get over the initial case conditions, the first case conditions, run. And when I run this, I get 1009 for my solution. There is my 1009. And if I do this for part 2, and I just change this, let me make sure just so I don't, there's a lot of zeros there. This is just, it just takes a couple seconds, about 10 seconds, I forget how long, but you should see then that my answer comes out to 62,714. Thought I would be done talking by the time it would come up, but come on, let's go. I'm going a little slower. There it is, 62,714. So this will work for any number. You just got to wait longer and longer because you really can't. Let's say you have to generate the numbers from the previous numbers. So you can't really say let's start at a location 2 million or something and go from there. I don't know of a way to simplify the process to figure out an individual number in the series. So there you have it. That's my code. I think it's a pretty good solution. If you've got a better one, as always, comment down below, and I'd love to hear about it. I'd love to have a conversation about this. So day 15 in the books. Let's see what day 16 has for us. I'm looking forward to it. Have a great day, everybody. Take care. See you next time.